Okay, so this is called, this chapter is called counting method. What is counting method? We have like couple of ways of rearranging things. So the first one, the first exercise is really easy. It's the really basic part. It's called additional and multiplicational principles. So additional is when you see the word or. Okay, when the word or associate, we'll use additional rule. So for example, I said I have 3 t-shirts and 4 skirts, and I will choose a skirt or a t-shirt to wear. How many ways I can wear my clothes today? That will be a plus. So it's a 3 plus 4. I can wear like 3 different types of t-shirt and 4 types of dress. So it's this or that. We will plus them together. And multiplication rule is when we use the word and. Okay, I have 3 t-shirts and 4 jeans. I need to wear a t-shirt and a jeans. How many different combinations do I have? So that's a 3 times 4. That will give me 12. That's the really basic thing, okay? All later on questions will base on that. Okay, so nothing to talk about in A, but B is important. B is called arrangement. So we have 3 ways to do arrangement. So first one is called a factorial. Second one is called a permutation. Third one is called a combination. So factorial and combination still important in year 12. Permutation is not. Okay, permutation is not. So I'm not going to talk about permutation a lot today. Factorial, what are factorial? So when you want to use factorial, you must understand that items are fully used up. So for example, I have 12 books. I want to rearrange them in a row. Okay, all the books in a row. And I can't, definitely I can't repeat it. So how many ways I can put the books in a row? So that will be a 12 factorial. Okay, that will be a 12 factorial. So in the first place, I can select 12 books. In the second place, because we already used up 1 book in the front place, I have 11 choice in the second place, and then 10, and then 9, and then, so you'll be something like that. Okay, we have 12 choices in the first place, and we select 1 to put in the first. So second got 11 choices, and then 10 choices. Until the last spot, I have only 1 choice. It's the only one left. So I will times all of that together. So 12 times 11 times 10 times 9 ... until 1. That is called a 12 factorial. Okay, 12 factorial is very important. So the more important thing is the calculation for factorials. Okay, n factorial is n times n minus 1 times n minus 2 times n minus 3 times until 1. Okay, we have a really important thing is 0 factorial is 1. Okay, this is a special thing. Okay, this is a special thing. You can just remember it. So 0 factorial is 1. So you can think about this way. There's 0 items. How many ways you can arrange 0 items? 1 way. Okay, nothing here. 1 way. So this is why it's 1. I have formulas to prove it, but I don't really like the formula proof. It's just confuse you a lot. So you can just think about in this way. I want to rearrange 0 things. Okay, nothing here. How many ways I can rearrange it? 1 way. We do nothing to it. Okay, that still looks like that. That's only 1 way. So that 0 factorial is 1. And also the formula in front of that is n factorial is n times n minus 1 factorial. Okay, for example, I have 4 factorial. So what is 4 factorial? I can say that's 4 times 3 factorial, because you can keep expanding 3 factorial as 3 times 2 times 1. I can also say that 3 times 4 times 3 times 2 factorial. Okay, maybe the number is a bit too small. I can go 6. That's 6 times 5 times 4 factorial. I can also do that. I can leave the term, like separate them as a number times another factorial. Why I want to do that? Because when I try to evaluate b, okay, have a look at b. When I want to evaluate b, I can do a simple calculation. That's 7 times 6 times 5. And I can say that's times 4 factorial. I don't need to expand it. And I want to divide by a 4 factorial. They can just get cancelled. And what you have is only 7 times 6 times 5. That's an easy way of calculate factorial divisions. Okay, so that's factorial is easy to understand. We have this much things. I want to rearrange them in a row. How many ways I can rearrange it is just the number of items factorial that. That's called factorial. And I will skip permutation, but I will still explain to you what is permutation. Permutation is when there's a group of things. I want to select this group of things out and rearrange them. For example, I have 20 books. Okay, and I have like a bookshelf, I can only contain 5 books. Okay, I want to select 5 books out, then put in a row. Okay, put them in a row. Order still does matter, okay, order still matters. We still care about the order to put things. So this is called a permutation. I select something from the big group and rearrange the things in that small group. So we will say that's a 20p5. It means we have 20 things. We select 5 and rearrange it. This is called the permutation. And the formula we use is n factorial divided by n minus r factorial. For example, this one, we can say that's a 20 factorial divided by 20 minus r is a 15. So divide by a 15 factorial. That's how many ways I can select 5 books from the 20 books and then rearrange it. Okay, so the requirement to use permutation is items are not fully used up. I only select 5 from the 20. I'm not fully used it. And then the order is very important. Okay, order is very important. I care about the order. And then each item can only be used once. Okay, one book cannot be put at 2 places. So exactly use once for each item. So this is called permutation. Okay, this is called a permutation. But in year 12, we don't really need permutation. Okay, we don't really need permutation. So you just need to understand it and do the simple questions. You don't need to care about the really hard ones. And we have box method when there's like special case happens. We'll talk about this later in exercise D, so we can skip that first. Don't worry about those challenging questions. Like those challenging questions is like not really important now. You can have fun with it. Like don't need to care about that too much. Okay, the most important thing is C. Okay, exercise C is the most important thing. It's like all we need to use in year 12. Together with the factorial thing, okay, together with the factorial thing, the 0 factorial is 1, that's really important, you need to remember that. Okay, selections. What is selection? Okay, when we talk about selection, we need to talk about permutation first. What is permutation? Permutation is there's a group of things. Well, let's just use our class as example. We have a class of 25, okay. Don't include me, I have 25. And I'm a teacher, I want to select 5 students as a group to put them in a row and then take a picture. Okay, so we need to select 5 from this 25. That's my first action. And then I need to rearrange the 5 students in a row. And there's more than one way to rearrange them in a row. So that's a permutation. I care about the order. Okay, I select 5 and not satisfied, and I need to put you in the order. So that's 2 actions actually. But there's another case. Okay, we have a math competition, and I just want to grab 5 students out to attend the competition. Okay, in this case, do you think the order important or not? No. Okay, when I take a picture, I can have different types of pictures when you A, B, C, D, and then A, C, B, D, like in different ways. I have different pictures. But when you go to attend competitions, you just sit in a room and do a paper and everyone get a mark. And there's no, well, it's not helpful when I rearrange you in a row. Like, for example, I select 2 students. Whether A stand in front or B stand in the front, they all attend the competition. That's the same result. There's no difference in the final result. So the order in this case is not important at all. Or say I want to select 5 students to attend the debate. So you just go for a debate. You are not going to be put in orders. You just these 5 as a group, as a whole to attend something. So the order in this case is not important at all. So this comes to the case called selection. Okay, this is called selection. So selection is just finish the selection step and that's it. Okay, I just select 5 and that's it without the rearrange. This is called a combination. So combination is very similar to permutation. We use C instead of P. So I will go 20C5. It means like I select 5 students from 20 students to do something. Okay, C is called a combination. I just select 5 from the 20 and that's it. How many ways I can, this means how many ways I can select 5 students from 20 students. So how many different combinations we can have to attend this competition. Okay. And we have some really important formula here. Okay, combination is we have the most number of formulas and we need to care about that a lot. First of all, just cross out the middle one because I don't think you can remember the permutation formula. So therefore, I'd rather just let you to remember the combination formula. Okay, so there's a connection between the combination and permutation, but I don't really want you to know that. We can directly come to the combination part. Okay, combination is n factorial divided by r factorial divide n minus r factorial. Remember, permutation is without the r factorial. Okay, without the r factorial. And in this case, in combination, I need to further divide r factorial. Have to think about it. The r factorial means how many ways I can rearrange r things in a row. Okay, I divided. Permutation will got more ways compared to combination. Do you understand that? There's more ways I can see in combination in permutation compared to combination. Okay, we all have NPR and NCR. This one is n factorial divided by n minus r factorial. But this one is n factorial divided by n factorial and r factorial and n minus r factorial. Okay, in the second one, I divide r factorial more than this p one. So I have less number in combination. Because that makes sense. I'm not going to rearrange the students. There's only one way as a group. Okay, instead of another 5 ways. So that's combination and permutation. First of all, you need to remember the formula. How do we evaluate NCR? Okay, how do we evaluate NCR? And I don't want you to like every time use this formula. There will be some quick ones. Okay, so what are the quick ones? Also, NCR can be write in this way. A big bracket and on top are at the bottom. That's another way to represent NCR. And we use that more. Okay, we use the bracket thing more. Okay, bracket and R. So there are 4 special things. Okay, there are 4 special things. What are those 4 special things? The first one is N0 is 1. N0 is 1. Yeah, as I said, like this is NC0 that equals to 1. Y is 1. Okay, Y is 1. Have a think about that. I have N items. I want to select 0 items from N items. How many ways I can do it? 1 way. Not selecting anything. Okay, not selecting anything. There are n things. I want to select 0 things from this. How many ways I can select it? 1 way. Okay, not selecting anything. Do nothing. That's only 1 way to do it. N1 equals to n. So it's NC1 equals to n. So why does n? I have n items, okay, in a row. I want to pick one from that. How many ways I can do it? Select the first one, second one, or third one, or the nth one. N ways, okay, n ways. I can select each of them like once. So that's n ways to do select one thing from n things. And there's another one, nn. So it's ncn that equals to 1. Well, that's easy to understand. I want to select n things from n things. How many ways I can do it? Select all of this, okay, select as a whole. So that's only one way to do it. And the last one is, okay, I forgot to write the last one here. So it's n minus 1 that equals to n. n minus 1 that equals to n. So for example, 4, 3 that equals to 4. 5, 10, 9 that equals to 10. Okay, so why is like that? For example, there are 10 things. I want to select 9 things from it. How many ways I can do it? Okay, you select 9 things. It will be the same as you leave out one thing, right? You select 9 things means you left one thing out. So how many ways I can left one thing out? N ways. I can left the first one, I can left the second one, I can left the third one behind, I can left the fourth one. So there are N ways I can left one behind. So there will be N ways I can select 9. Select 9 and left one out will be the same. So there will be N ways to do that. So there are the 4 important formulas you must understand. Remember them, okay? Remember them. You must directly remember. And we normally just use those 4. We don't ask you to really evaluate really complex NCR questions. So those 4 formulas are really important. Okay, the next one is that Ni will be equivalent to n minus r. So what that means is, let's go for 7, 4. That will equivalent to 7, 3. 8, 3. That will be equivalent to 8, 5. Okay, so if the bottom 2 add together will give you the top one, then those 2 numbers will be the same. If you use the formula expand all of it, you will see the result. You will see the result. But like, you just need to know they are the same. Okay, they are the same. So you select 4, I can explain this way. You select 4 things will be the same as you select 3 things. Do you understand? Like, because you have a group of 7, you select 4, you left 3. Okay, you selected 4, you left 3. Then they are the same. When you select 4, it's the same as you left those 3 out. And you select 3, it will be the same as you left 4 out. So that's a pair. So the pair must be the same. They must have the same number. Okay, so they are the same thing. Okay, they are the same thing. So I'll talk about more about the NCR one. Let's have a look about question 2. Question 2 is the most important exercise. Okay, a committee of 5 is to be formed from a group of 8 men and 7 women. So I want to select 5 people from 8 men and 7 women. So how many people are there in total? How many? 15. So I have 15 people here. Among those 15 people, 8 are men and 7 are women. In how many different ways can this be done if there are no restrictions? Okay, I just want to select 5 people from those peoples. How many ways I can do that? Just give me expression, it's fine. I don't need you to evaluate. You have calculator to evaluate this. How I can give the expression? Anyone? I have 15 people. 15? Well, it's C or P? C, because the order does not matter. They're just involved in the committee. So it's 15 C 5 case. Okay, I don't care about man or woman. You just have 15 people here. I can select all men, I can select all men, or I can select a mix of them. Okay, so I would like to write in this way. I want you to get familiar to this notation. So it's a bracket 15 and 5. Even though there's no C, that will be the same as the C thing. Okay, B is a little bit interesting. Kate must be involved in the committee. What do you say about that? Well, Kate is someone. There's only one Kate in this group. What I can do? How many I need to select later? 4. Among how many people? 14 people. So what you can treat in this question is like 2 subgroups. Okay, not man or not woman. I just care about Kate. I don't care man or woman. So I can go, there's only one Kate. And 14 others. 14 others. Okay, they are not Kate. They are not special. So what I want to do is, I want to select one Kate. Then I must select 4 others as well. So there are 2 subgroups. It would be equivalent to say, I select one from the one that's the special group, and I select 4 from the 14 group. So we times that together. Well, 1 is 1, you know that. That will be just equivalent to 14 But like, this expression will give you more understanding. That's like 2 subgroups. I will select 1 from one subgroup and 4 from the other subgroup, and we times that together because it's an AND relationship. I want Kate and the other 4. Okay, Kate and the other 4, so it's a times relationship. Okay, so when you know this, let's have a look at C. The committee must consist of 3 men and 2 women. What I can do? Yep, so we have 2 subgroups, man and woman. We care about man and woman. So I want 3 men and 2 women. So we have 8, 3 times 7, 2. You must exactly select 3 from the 8. That's how many ways I can select 3 men from 8 men. And the 7, 2 is how many ways I can select 2 women from 7 women. So I times the number of ways together. That will give you the total number of ways I can do this. Okay, D. The committee must consist of at least 4 women. What I can do? At least 4, which means how many women I can have? 4 or 5 women. Okay, I can have 4 women or 5 women. So if I have 4 here, well, I don't want that. If I have 4 women here, how many men I need? 1. If I have 5 women here, how many men I need? 0. So that will be case 1 and case 2. So the first one, I can say I want 1 man from 8 men, and I want 4 from the 7. Plus, because it's 4 women or 5 women, so it's an or. So I will add them. I will select 0 from the 8 subgroup, and I want to select 5 from the 7 subgroup. And we plus those 2 situations together. That will give you the number of ways I can have at least 4 women. If I can say at least 4 women, I can say at most 1 man as well. Okay, at most 1 man as well. Alright, that's a really important question. Year 12, we use this type a lot. Okay, just exactly this question, exactly this type of question, but involve probability. We'll talk about a little bit probability later, but that's the fundamental. That's very important. So how we select things from different subgroups. I can also select things from 3 subgroups. You just times another subgroup as well. Okay, I can have 4, I can have 5, not only 2, but I just times all of that together and choose the correct number I need to select from it. Okay, I don't want to do next page. Next page is not really important. I can just look at exercise D. For exercise D, let's start from the beginning. We are talking about probabilities. What we all talk about before is we talk about the number of ways I can do these things. Okay, this is the number of ways I can do this. So it's like I have 1,000 ways to select 5 people from the 15 group. Okay, so that's the number of ways. And now I want to connect the number of ways into probability. Okay, into probability. So let's have a look at the first one. Let's have a look at the 1, 2, 3, this number here. The first one will be determine the total number of possible outcomes. So what's the total number of outcomes? For example, the number of selection questions for the previous question we did. There are 15 people, I want to select 5 from it. When there's no restrictions, that's the total number of possibilities, number of ways I can do this. I just want a group of 5 from 15 people. That's the total number of ways. Second is determine the number of outcomes in the events of interest. So what's the event of interest? I want 3 men and 2 women in this group. Okay, that's my interest. It's still a group of 5, but I need the gender in particular numbers. So that's the number of interest. So in the previous question, A will be the total number outcomes. And B, C, D, they are all called of events of interest. That's different events of interest. Okay, that's different event of interest. So B is the event of interest that Kate is involved. C is the event of interest that there are 3 men and 2 women. And D is the number of interest that there are at least 4 women. So they're all different types of number of interest, but they are the events of interest. And number 3 is required probability will be the number of outcomes of events of interest over the total. So this is the total number of ways. And this subgroup will contain Kate in this event. So you use this small group to divide by the total. That will give you the probability. Yes? So they are equal likely events. And I want to have this many of events involve Kate. So this will divide by the total. That will give you the probability. So D is talk about that. Okay, really easy exercise. Let's have a look at number 1. Number 1 says there are 4-letter words are to be made by arranging letters of the word special. Okay, 4-letter words. Okay, 4-letter words. So it's not really words, so it's just 4 letters and rearrange them to form something. What is the probability that this word will start with a vowel? Okay, this is something really, I'm not going to talk about a lot of it. So first of all, I will talk about the total. So what is the total? I have 1, 2, 3, 4, 5, 6, 7 letters. I have 7 letters. So the 7 letters will select 4 out, and I need to care about the order. So it's a permutation case. 7, I will select 4 out and rearrange those 4 to give you a total.
Why would you select 3?
No. We care about total first. Like how many different words I can make in total. So it can start from word or not start from the vowel.
So how many different 4-letter words do you need 4 to select?
You need to 4 letters to. You need to select 4 letters first and then rearrange those 4 letters to make a word. That's the total. But 2 is, as you said, interest. My interest is start from a vowel. So I have a 4-letter words. Okay, that's the 4-letter words. How many vowels are there? 3. So I can put only 3 letters in the first place because I won't start from a vowel. So then what I put in the second one, I don't really care anymore. So I have 6 selections because I already put a vowel in the front. 7 letters, reduce 1, I only have 6 for the second box. And then 5 for the next box. And then 4 for the last box. Okay, so that's the number of interest I can have. So it's a 3 times 6 times 5 times 4. That's the number of interest. That's the ways I have interest. Okay, so I must start from a vowel. There are 3 choices I can put. And then the second box, because already you select one, I don't know which one, but I have select one vowel to put in the front. So I only have 6 selections for the next. And 5 and 4. Okay, and 5 and 4. So that's the number of ways of interest. And number 3 is the probability. So it's the probability start with vowel. Okay, start with vowel. So that equals to 3 times 6 times 5 times 4. Divide by the total. 7p4. Okay, 7p4. That's the probability. Because that's the total number of events. And this events already including the situation I start from the vowel. And this is the number of ways I have the vowel. I will use those to divide to get the probability. They are equal likely events, so I can use the number of ways I have interest over the total. Okay, so I have the probability here. That's how we do this type of questions. So I want you to try example 2, 3, and 4 before next lesson. So next lesson I'll talk about 2, 3, and 4. Okay, so I want you to have a try first. What you need to do is 3 steps. First step, you think about the total. Second step, you think how many ways I can achieve the interest events. And number 3 is use the number 2 outcome divided by the number 1 outcome. And that will give you the probability. So that's what we need to know and use in year 12. Okay, this exercise is important. So I want you to have a try. You have 6 minutes. You have to try first, and Wednesday, we don't have class on Wednesday. Thursday, I will talk about that and talk about Pascal triangles.